Okay, my friends, this would actually be kind of funny if it wasn't a billion-dollar disaster. They're saying scientists start a crazy multi-million-dollar plan to catch dark matter by studying rocks. I do both of those. And I have already found dark matter, and rocks are not just rocks. Okay, my friends, this is going to be fun, a lot of fun. They're starting a crazy multi-million-dollar plan to catch dark matter by studying rocks. Well, I'm pretty deep into both of those subjects, and I have actual experiments on both of those things. So let's see what they have to say about dark matter and what they have to say about rocks. Before we do that, I'm just going to show you dark matter and show you that the dipole electron flood theory, which is my theory since 1970, is truly what matter is made out of, is dipoles. It's not made out of gigantic, huge protons and tiny little electrons. No, it's made out of dipoles. They're all like bar magnets, and you have a certain number of them, which appears to be around 1840-ish, makes one proton. And that's my dipole electron flood theory, and I can show it to you. And I can show you that light, first of all, has mass. It can be accelerated. Virtually everything that they're thinking is not correct. So I'm going to show you my evidence, and then we'll see what they have to say. Okay, my outstanding friends, before we even start, this is not made for kids. This is made for people that are scientific. Kids, I find, are the most scientific, but it's not made specifically for kids. But I'm going to tell you something right now. If you have anybody that you know that wants to get educated, whether they're a kid or an older person, it doesn't make any difference. Physics has to start completely over, and I'm going to show you why. And we found the particles that Fermilab found, only we found them using light. They found them using a destructive smashing particles together, and they found the two particles, but we know they're attached as light, and we can split them as well, and we did, which changes everything in physics, because light has a mass. The photon has mass. It can be accelerated, it can be divided, and it is a dipole. Now let's see what chat has to say if those things are true. All right, I'm just going to read you the highlights real quick. If photons were found to have mass, even an incredibly small amount, it would lead to significant changes in understanding of physics, and here's how it would impact various areas. Electromagnetism, they really don't understand it now. Photons are massless particles in the standard model. They are not massless. Photon mass. If photons had mass, Maxwell's equation, all this equations and laws and all that stuff, they're all nonsense. I did all that stuff. I can show you. I'll show you again. Look, I did all of that stuff. I did it all. And I came out with the conclusion that it was just all nonsense. I just wasted my time. All these bonding theories and this and that. But I did understand that everything was made of dipoles, and that I could have calculated energies, and I did a lot of stuff that was hands-on stuff, and I came out with these theories that the transfer of energy was from light to atomic vapor, and that everything was made of dipoles, two types, dipole, dipole. You got polar and non-polar. So they can be magnetic, they can be non-magnetic. Anyway, it goes on and on. The summary here, this goes really on for a long time. Everything would change, literally everything. So, for some reason I can't scroll on this, so let me read what it says. It says, there's an in summary part down in here somewhere. Well, it says everything would change. All right, here it is. In summary, discovering that photons have mass would require a fundamental revision of many physical theories and have profound implications for understanding of the universe. And it does all of that. And if you know anybody that wants to get into physics, now is the time. It's wide open. Everything has changed now. 100% has changed. So if you have anybody that's a student or a friend, or even if you want to change your occupation and go into physics and start to go into the real, true physics, this changes everything, 100%. I'll show you photons, no question whatsoever, that have mass. Zero question. All right, this is from our light experiments. These are dipoles. That's a dipole, and that's a dipole. Back to back is just like having two bar magnets. And here's just, this is what it is. This is colorized, which is really what it was, because it was a red laser. As a matter of fact, this right here it was a construction laser, pulsed red, boop, boop, boop. Now, what happened was these dipoles being attached together is the smallest particle there is, basically, until you get into the split, which we did split these, where you have electrons and then you have sterile muons, with just the black and just the red. And these are from Fermilab, and they say, yes, these are the smallest particles that exist. And I agree. And they are from light. Light is much smaller than any matter. It's all over the place. There's light coming everywhere. It's just so small, it doesn't really have any interaction, but it bounces and you can see it as a glow. That's what light is. It's almost nothing. It's the tiniest particles, as you see right here. But they're the tiniest stable particles. When you get above that in particles, the next time you get stability is when you hit about 1839 or 1840, somewhere around that area. And then they lock in to become protons. And that's where you end up with these zones of stability, periodic table. All these are is zones of stability. A hydrogen is like 1840 particles together, and then it locks up, it becomes pretty stable at that point. It can still fall apart. Plus it can have extra particles or less particles. Those are called isotopes. Helium, same thing. You can have, this is like 7,300 particles just for helium. Those are the two smallest particles that exist. And as you get up into these heavy ones, you've got literally hundreds of thousands of particles. And not just 90 or 85 or whatever, and a whole bunch of neutrons. You got almost 2,000 times every atomic mass. Okay, so let's take, well, hold on, I can't see it. Let's just take, let's say gold. Au is 197, all right, to 79 protons, and the rest are neutrons, basically. So you take, say 200 times 2,000. All right, so what's that? 400,000? Whatever it is, I'm not good at math. Okay, my friends, this is going to be, I can show you everything you need to know right now to understand really the truth about physics and the truth about light, which is a particle. It has a mass, it has a huge magnetic field surrounding it, which causes a wave as it goes through the air. So you see the wave, and that's the particle. The particle does have a mass, totally not understood. The particle is a photon, and it's light. And that is exactly what it looks like, because that is an exact experiment showing the particle. Now, when CERN and Fermilab smash their things, they're not using light. They're using huge particles like that, and they're seeing all kinds of debris. However, they do see these two particles, and they say they're the smallest particles that exist. That's the two particles. This is from Fermilab. That's not and I'll show you Fermilab's article about it. And this goes back 10 years. They have a glowy edge around them, and they have all the weight, and that has no weight whatsoever. They call it I forget. They have some name for it, but it's a point particle, which means there's just nothing there. And we found the same thing. There they are right there. It's exactly. But they're attached together. They're not just separate. Although we can separate them, and we did. We did it different from them. They hit them head on and they splattered everything everywhere. We forced it through a venturi, and here's the venturi. Don't forget, these are tightly, I mean tight attached. They do not want to come apart. However, when you put them through a venturi and accelerate the light, which also is not allowed in their world, Fermilab and Einstein and all the rest of them. Well, that's acceleration. I don't care how you... So let's ask Chad about that. What if light could be accelerated, not even in a vacuum? This is not a vacuum. This is right here in the air. Pew! Taking off like a rocket. When it hits the venturi, because it's such a tightly tuned orifice there, it guides all the fields together and they collide sideways instead of head on. They're trying to hit them head on. Very, very difficult. It goes that way, it goes this way. Out of billions of particles coming at each other, they only get about 25 hits. Billions at a time coming, and they all just keep getting out of each other's way, except every now and then they hit a head on. Here, virtually everything is being crushed. You can't get out of the way. And here's what it looks like at the venturi, if you were right there looking at it in the face. All the black particles stay back, and all the white, not all of them, but most of them go through. And then they recombine with the black over here. Now, this point brings up the point of entanglement. We saw the black and the white were entangled. They would say that's quantum entanglement. This quantum realm, we're down below the subatomic, and this is quantum particles. And they are entangled. There's no question whatsoever. And photons are two entangled dipoles. And every dipole is an entangled positive and negative. Basically, you could think of it that way. But they're glued together. That one there has all the energy. You can get big and small. See, big, small. Never changes size. Never. And the only reason this one's getting bigger, it's going forward through the air that way. It's concussing everything. I could show all of this stuff with the experiments. No problem whatsoever showing you this happen. And we use CMOS, nothing more than a regular cell phone. CMOS means complementary metal oxide semiconductor silicates. And it's used to see these kind of interactions, which is light. It's particles this big. All right? It's not particles this big. When CERN and Fermilab tried to use CMOS, they couldn't do it because they hit it with things like this and it would destroy the CMOS. And I spoke to University of Geneva when I went there for particle physics, and I told them we were using CMOS, and this goes back many, many years ago. And we could see these particles. And at that point, it was a discussion that, no, you can't see them because it'll destroy the CMOS. Yes, I can see them because I'm only using light. No, you really can't see them because that's impossible. They're too small. No. CMOS is a whole different story. Every pixel is designed to see illumination, to see photons, is built for that specific purpose. And then every single pixel has its own amplifier. It's a whole different story than taking just pictures. Now, and as a matter of fact, CERN upgraded shortly after to use CMOS, that they hardened it somehow to keep the big particles. Let me just show you something. Now, light is part of protons. It's the smallest little bits of particles that exist. It's a black one and a white one together is really an electron. That's the dipole electron. All right, so here's the proton. You can read it very simply. It consists of around 1839, 1840 dipoles together, but the black goes to the center. So anytime you look at anything, all you ever see is a white. But if you could see inside, there'd be a black core right in the side. You never see it. We saw it because of the experiments we did, and I'll show you. These are the only two particles that exist. They're the only two particles. There's a dark muon, which has all the mass, and that's what we're standing on in the Earth, is muon mass. The white electron has no mass whatsoever, none, zero. It has no weight, none, zero. It has all the energy, 100%. That has all the weight and no intrinsic energy. It has energy if it's in motion. That's dark energy. This is dark matter, no energy whatsoever. If you took every electron out that was extra electrons, the white ones out, you would have absolute zero. That means there's no heat whatsoever, because those are the part that's heat. That's what absolute zero is. You keep pulling away the electrons. It gets colder and colder and colder and colder and colder until that's all you have left is the dark matter, and there's just nothing. Well, there's no extra electrons. You still have your particles, but there is absolutely no extra electrons. And what does extra electrons means? It means heat. If you heat this up, it gets warm. But if you put it in a cold area, it leaks back out again. The electrons leak back out into the cold. So if you keep sucking cold out of here, there won't be any extra electrons left. And that's when you hit absolute zero. And there's a certain temperature, I can't remember what it's like. I think it's 451 degrees below zero, something like that. I can't remember. But it's way, 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 way below zero. And once you hit that, it's done. And it's virtually the same situation as when you hit the ultraviolet catastrophe. And that's when light loses every electron, and all you end up with is the heavy dark particles. And those are heavy X-rays and gamma rays. This is fully understood now, absolutely fully understood. And I will show you, and this is the differences. This is an electron. It used to be, they always thought it was just a white glowy part. No, it's both. And this pushes the electron. It's called a boson. No, I don't know. They got so many different names now. But a photon is a particle of light. They say photons have no mass. That is incorrect. The black has the mass. This has no mass. And the reason I can tell you it has no mass is because I can prove it. And secondly, when you fill your car up with electricity, which is this part, the car gains no mass whatsoever, but again, a ton of energy. If you put this in there, you're going to have a bunch of mass goes in the car. We only put that in, or whatever you're charging up for a battery. Whenever you just put the white ones in, that's it. You're done. No weight whatsoever. You drive all day long, you come back, it still weighs the same amount. You fill it up with electricity, still weighs the same amount. All that energy is all bundled up in that white part. And we can separate the white from the black. We have done it. And there's some changes to science and the changes to chemistry, space, redshift. That's not credible whatsoever. Redshift is light slowing down. And I'm going to show you all this stuff. So what we need to do is just understand got to start over with a new particle. Everything I write here, I can prove every single word I just said. Watch. Okay, you probably know, if you've been following me, this is my theory of what the proton actually looks like. Everything is made of dipoles, and it's called dipole electron flood theory. Dipole electrons. If electrons are dipoles, which they are, it changes everything there is in physics, which it does. And if photons have mass, which they do, it additionally changes everything in physics. And that's not just my words. All right, so I know to the average science mind, the things I am saying and will say are shocking, but it is true. I showed, or will show, I think I have shown you, that electrons are dipoles. And here is artificial intelligence. This is Google. If electrons were dipoles, it would significantly impact our understanding of physics, change everything in physics. Primarily introducing new interactions, behaviors, electric fields, potential for electrons to align with electric, all kinds of things. And it goes on and on and on. And then it would do everything. This could lead to new phenomena in material science, particle physics, electron behavior, crucial, all kinds of things. All these things would change. And then at the bottom it says, though, important considerations. All this would change if it was true that it dipoles, and they are. It says the standard model of particle physics predicts a very small, almost negligible electron dipole moment. Well, they never predicted anybody, but any at all, but it's huge. It's very, very powerful. Now, they would say detecting a significant electron dipole moment would be a major discovery. I just showed you one. just held together, just as strong, as powerful as can be. Major discovery, implications for fundamental physics. Now, this is all brand new. This is new physics, my friends. I know it's a shocker. I'm not well known in the business, and it is a business, trust me. And I'm not well known and I'm not well liked, so I'm presenting my facts. If somebody else can present their facts against mine, that's what I'm looking for. Now, I also am talking about mud fossils. That's another range that's just totally ignored, and the reality is material, and I can explain that. And I'm also talking about space things, the things that are in space. Bennu is an asteroid. They just landed on it, brought some stuff back, and are analyzing it now, and hope to analyze it for the next couple of years before they even, and I know exactly what it is. I knew what it was before they even came back with it. I'm going to show you some things here that you have to confront your professors and teachers and everybody around you and say, we're not thinking right here. Maybe I'm wrong, but let's take a look. Don't try to be confrontational. That doesn't work well. But just say, what do you think about this? Look at this. This is kind of crazy, but it looks like it might have some evidence here. What do you think? Ask questions. Anybody that really thinks and is presented with a question and some evidence to support the question that is being asked, if they're a thinker, they should look. And I found very few. That's just a fact. I'm going to show you the things that you should start asking. All right? All right, I'm quite sure I've shown you this, but this is Bennu, the one where they landed up here and took a sample. This is what a heart is when you break the plumbing off the top, which comes right off. Right from there, it comes right off. It's just basically glued on there. And here's Psyche, which is another heart in space. They're identical. The valves are here. The tendon is here. And Psyche has exactly the same thing. Only Psyche got close to something that heated it so hot, it turned it into like a metal asteroid, a metal meteorite. Only not deep inside, I'm sure. The surface is smelted, yes. It's kept its structure. It didn't turn into a ball of metal. And sometimes they will completely, totally turn it. But the blood will still actually be inside. And I can show you that and prove it. But they break off here, and what we're seeing here is these valves. And if you look closely, you're going to see all of the little tweaks coming out of it, which are the actual fibers. I've shown this way too many times. And this is what Bennu looks like to just look at it in space. And they were right there. So these are not artist renditions. This is real. That, my friends, is a tube. And that, my friends, is a tube. And most of these little pock marks here are explosions outward from the wet fluids being boiled from the light hitting it. This is the tendon that locks the muscle into the heart. I've shown this over and over and over and over. I can't say it too many times. All of these little fibers, you see those? Those are the fibers of the valves, of the heart valve going in. It can't be denied. If they don't have anybody that knows chemistry or biology or physics, I can't believe these people can be not able to understand this. I don't want to call them incompetent, but I mean, what are you going to say? And then you got people like Mikio Kaku talking about the God equation, and they there's body parts in space, Mikio. And here's the proof of it right here, is this heart sarcomeres. There's no question they're heart sarcomeres, layered by 2 layers of phosphates, which are phospholipid membranes. Not hard to understand. You see this? This is Bennu, which I showed you is a heart. I don't care what anybody says. There's no way to deny it. And they came back, it contains carbon and water and all of the molecules that are in the human body. and it contains sarcomeres, which are muscle, and it contains phosphate layers, which are the membranes. Now, listen to what they have to say. This is NASA spending billions of our dollars. Listen to this. Listen to high content of carbon and water indicate the building blocks of life on Earth may be found in the rock. Everything there is made out of these building blocks, which is called biology. All right, now, I hate to be this way, but I have to be vocal about this. This is over a year ago. They said our labs were ready for whatever Bennu had in store for us, said Vanessa Weich, director of NASA Johnson Space Center. We've had scientists and engineers working side by side for years to develop specialized glove boxes and tools to keep the asteroid material pristine and to curate the samples so research now and decades from now can study this precious gift from the cosmos. It's a heart. I got to be honest with you, this is not really good. Listen to this, they got it all figured out. For the next 2 years, the mission science team will continue characterizing the samples and conduct the analysis needed to meet the mission's science goals. Well, what do they want to find out? What is out there? What is it part of life? Yes, it's already done. NASA will preserve at least 70% of the samples at Johnson for further research by scientists worldwide, including future generations of scientists. As part of OSIRIS-REx science program, a cohort of more than 200 scientists around the world will explore the regolith properties. This is what they brought back, including researchers from many U.S. institutions. NASA partners JAXA, Japan Aerospace Exploration Agency, Canadian Space Agency, other scientists from around the world. Additional samples will also be loaned later this fall to the Smithsonian Institution, the Space Center at Houston, and the University of Arizona for public display. I've seen them. I know what they are, and you know what they are. They're heart sarcomeres. Okay, here it is right here. There's Bennu. And this is what a heart looks like. This is this. And that's the core of the heart. And the plumbing is all broken off. And you can see these little valves in here. That's exactly what you see. And then there is some tendon that's also still attached to here. But this gets right down to the muscle banding, because it's one big wrapping of muscle, and it just twists. And that's what gives you your heart working. But what they found here is heart sarcomeres. And what is a heart sarcomere? Well, here's one in an actual heart attack victim. Right there, this is what the heart sarcomeres are. This is ripped, torn heart muscle. That's what it's supposed to look like. Those are heart sarcomeres. There's a layer of phospholipids, upper and lower, which turn into phosphates. And the rest is red muscle, basically, is almost like clay. That's exactly what they say. There it is right there. There's no difference. Zero difference. The top is phospholipids, which is the membrane. The bottom is phospholipids on top of the heart sarcomeres. And they were, wow, phosphate surprise. We never expected to see phosphates, especially in layers, especially around heart sarcomeres. Let's just forget about that. Don't talk to Roger. I've been trying to get through for over a year to talk to anybody. And they're, we're giving it to everybody. Everybody's going to look at this stuff. Well, I'm looking at it, and you're looking at it. What do you see? I could be wrong, but I don't think I am. Phosphate layers, sarcomeres, a heart. I mean, that's just what it is. And that stuff breaks right off. And I talk to autopsy anatomists all the time. And they say, when it comes out, it just basically comes right apart. It just snaps right apart. It falls apart on this one specific line. Right across there. Because this is just all the plumbing. Pops right off, and you have the bucket right here. And you have the valves and the little... Everything's there. You cannot dispute this. They want to take another 2 years to study this? We need to study what our universe is literally made of. And when you see this right here, this is where they landed and took the sample out, point of impact. Well, you see this red and the black and the yellow? That's the colors of blood. And you want to see what an actual mud fossil can preserve as? With the red and the black and the yellow in a heart, which this is? Well, let me show you. All right, you want to see how fabulous mud fossils can preserve? This is the left atrium, and red blood leaked out of a small area where the tube came out of on a mud fossil heart. A friend of mine found this. Unfortunately, he's passed away. It was Phil Harris, fabulous guy, and he found this with the 15-minute challenge. He went out and he found a rock and he saw a red spot on it. Let me show you what he did and what he found when he just tapped it with a hammer. It split wide open, because that's what they do. They split right on that seam. All right, so Phil finds this rock, and this is the coronary artery, and I believe what he saw was right in this area that red blood leaked out. Now remember this shape, and he taps it here, and the top comes right off. Now watch this. Now this is what he did. He popped it right here, and it just split right at the top. So we got all the plumbing came this way, and the buckets with the blood are at the bottom. Watch this. All right, this is just shocker du jour after shocker du jour. Here's Rod's heart. He hits that red spot, and it just cracks right across, and the plumbing comes off. And it's still wet red blood, and you see the yellow, and it's really yellow, and that would turn black if it was exposed for a longer time. And this is the red. Now, what we're looking at red blood. This is the spot he saw, and you see it's a round circle. That's where a tube would have come out, and it just sort of leaked a little bit, and he saw it, and he just went whack, and it just split right there, just exactly like they say in the autopsy. And you can see these are other tubes coming straight up, and here's the top. He took it off like this, and here's the top, was already oxidized. Where's the top? Rod, here it is. Now, that's the top. If you put that back on the other piece, these are the tubes. And that's the big red bucket that gives you, and that's the one that would turn black, and there's the yellow. Those are the three colors of blood that are the same three colors of the blood where they landed up on Bennu, which is right here. Now, I have a little meteorite here, which also has these same colors. It came through space. It's small enough that it didn't smelt completely. But when they do smelt completely, they just turn into a ball of metal, but there's still blood in them, just like this one right here. You see that? There's the blood right here. I'm going to show you a closer shot of it. But whatever this was, and I think it was probably a liver, because that's my take on this. A liver is primarily just loaded with metals and blood. Now, that's your red blood, and that's the vein blood, black blood. So here it is closer. You see the red? It's red blood. They can test that. I know they can test these things now, and there's the black blood. That's the standard, red and black, and then yellow is between somewhere. It's either the serum or the lymph or whatever it is, but it's in the heart, so there's no question. There it is, the yellow. And we know the red and the black is there too, and that's the top of the heart. You put them together, you got a heart. And they split right on that seam. And that's the seam right there. The top comes off. And that's what we see on Bennu, is this part down. Now, we spent billions of dollars to do this. Why can't we deal with the truth? And instead of saying in 2 years maybe we can figure out something. It's been here for a year. Before I even hit Earth, I said that is a heart, which you can't miss it. And it will have blood in it. And what you're going to pick up on that asteroid from this spot will be some kind of blood. Now, was it red blood? Was it black blood? Was it yellow blood? It looks like, I don't know. but it's going to be one of those variations, but it doesn't matter because they all have the same basic chemistry in them, only this is the different states of oxygenation. Right? That's why they're different colors. But they're still going to have the same basic different types of metals in them. So there's really no way they can miss analyzing this. There's just no way at all. And I'm going to show you right now. I have a heart right here. I mean, a lung right here that has these same colors in it, which is an asteroid. Time travel. Can say this? No, you cannot reverse time. I'm sorry. Time goes one direction. In my mind, I could be wrong. Show me something that went backwards. Although gods, they say they can do just about anything. Now, I don't know if that's true or not. Can they go backwards? I don't know. That, I think, may even be not possible for a god. Who knows? All right, this is the little lung that I have here, which is an iron meteorite. All right, it's not really transition because it's very small. You see my fingertip, how small that meteorite is? Now, each one of these little holes up here is an alveoli. And they had air and blood in them, and they exploded outwards. That's not caved in. Now, you see this black stuff here? I put water on it because water usually brings out some good details. And you see all the blood, it's everywhere. The blood is all over these spots. Now the black, let me find a better spot. Some cooks off differently in different areas. Let me see if I can find, hold on, that should be a pretty good spot. You can see the white. All right, here's what happens. When bloody stuff really cooks, it turns black. All right, it's just like black on your grill. These little white fibers are supposed to be completely saturated everywhere on this thing. But most of them burnt off. Almost all of them burnt off. You can see a couple little fibers here. You see the little fibers? There'll be other places you can see them. See the little fibers there? But mostly they're cooked off. And that's, see, this is just raw blood. And I know it's blood because I put hydrogen peroxide on there and bubbles like crazy. But this is cooked up and there's still some white fibers left. And all of the rest is just blood. That's the red and the black of the blood. Now there'd be yellow in here, but you only see it before it changes color, I guess. I don't know. Because I don't see any yellow in this. Well, you might say, actually, hold on. Hold on, I gotta get this in I think we got some yellow right here. You got your yellow right here. Hold on a second. All right, now let's turn the lights on. This is where you really need to be able to adjust the light. Here's your yellow right there. It's red and yellow, whatever you want to see. Now this one here is maybe better. Hold on. Wow. You can see there are all the tubes running down into it. I suppose you could see some of that as being yellowish. Let's put it this way. There's several different states of transition of oxygen here. There's the red, there's the black, and there's the semi-yellow, there's the fibers. Let me show you what a lung looks like when it's pristine and it has all of its white fibers. You see that? That's on that meteorite that I said is a lung, and that is the spurlock. And that is on that lung. And you see it? It's a totally different substance than below. And that's what I have found on all the lungs. They latch with this particular latch. And actually all the body parts. That is a whole new body part. It's never been known before. and that latches all the parts. You see my size of my finger compared to there? That latches all the body parts to each other, and I have other samples of that. Now, the other thing I wanted to show you was the texture of that black and white membrane stuff all over. It should be all over. You see it right there? The black and white little bits and pieces, but it's the black is cooked red. That was red at one time, and now it's black because it just got cooked up, and there's just some few fibers left. This is what it would have looked like when it was new. This is like, I mean, that's just absolutely flawless. That is completely perfect membrane. Completely perfect membrane. Absolutely flawless. And this is saturated with blood right down here, which I took blood out of here and sent it off to be tested, and it is human. And that came from the Great Flood. It's flat as a pancake on one side. And I have a bunch of them here. This is another lung that the pleura has halfway come off. This is pleura, they call it. You see it's how it's eroded halfway? That's another lung. Flat as a pancake, just like this one, because it died in the Great Flood. MIT says, yes, the oceans boiled. And when they did, they cooked the creatures, and they actually boiled the flesh off and left this, which fascia facilitated fossilization. I have, and then this has the spur lock on it as well. Right there is the spur lock that I just showed you on this one that came through space. This is a lung. There's nobody can deny this. And I'm almost absolutely guarantee you they can get some form of a DNA result out of here. And all the meteorites have blood in them. I showed you that. Every single one I have seen, 100%. They have blood in them. Want to see the giant one here? And don't forget, that's red blood. Here's a giant one that they took from the Indians, the Native Americans, somewhere around here. Maybe I didn't. Yeah, here it is right here. That's the Willamette. And right there's blood. There's blood right there. That was a huge meteorite. Now, why wouldn't that have exploded into little bits and pieces? I have come to the conclusion that either they're tiny, and when they come through space, they don't have enough friction and so forth to cook up enough to totally melt, so they just blanch. However, it's still turned into to iron. It will attract magnets. Hold on. And I have a lot of meteorites here. I don't have just one or two. I have a lot of them. You see, it holds on to magnets. It's strong enough that it's in the midst of being turned into really solid iron. That baby there is just basically solid metal, not just iron. It's all the different blood metals. Now, so you saw this is a lung. There is no question. It has the spur lock. It has all the alveoli. It has the red and the black. It has all the fibers. I just showed you the lungs that have the fibers. That has blood in it. This could be tested. There's no reason that shouldn't be able to be tested. Now, I got to show you something that just absolutely, totally fractured my mind. Wait till you see this. You see these? They call these laterite rock stone bricks. They're rock. I don't think these are anything other than just actual rocks. I don't think they poured these or did anything. They came out like this, although I don't know. But I'm going to tell you something. This is almost identical to my countertops. And I found something in my countertops that blew my mind, as I'm going to show you again. You see these? See all these little fibers and so forth that are in here? And the different colors? Now, did they pour these and make these? I don't know. That I'm not sure. They call them laterite bricks, but I'm going to show you my countertop. Now listen, watch this. This is my countertop. All of this stuff is ground up fascia. That's what the fascia looks like. Remember the lung I showed you? Let me show you again. Remember these white and black and red and all of that. Now, this is primarily white. Primarily white. You don't see any metals in there except that one little piece of metal. All right? And I believe that's some kind of, I'm not sure what it is. But it's the only piece of metal I could find in my whole countertop. And there's a lot of countertop. So, what do I take away from that? I think somebody ground up the flesh of these gigantic creatures and dissolved everything out of them, which would be most of the red blood would come out. The bloods would come out, and also the metals would come out. And what they would leave is the scraps, which are the tendons. Maybe. I know that this stuff must have come out from some, they must have cut my countertop off of some big gigantic piece of stone. It's because it's, you know, it's good, it's pretty thick, and it's hard as hell. And this is a real close-up of that shot. That one spot. Now, it's attached to blood. Blood attaches to metals. Nowhere else in the countertop could I find any other metals. I just couldn't find them. So I'm thinking that they dissolved these and cut up all that flesh. Don't forget, the lungs were had that same stuff. This is the same stuff. Same. Only they must have been thicker than hell, and they cut it up and ground it up, because there's a ton of blood in here too. The blood has the metals. The metals are in the lungs and the heart. That's where the metals are. And they must have been mining the metals out of there, and this is the leftovers. I can't think of anything else. Now this is, remember I showed you this gigantic heart? This is that little tiny hole right there, right around there. Watch. There it is right there. There's blood there. That's the Willamette meteorite. Why doesn't somebody test all this stuff? I've been showing this stuff for years and years. There's just no appetite to change the idea of what they have been forcing you to say at the colleges. And they say you have to have a core degree to get a degree. What's the core courses? Core curriculum. It means you have to say, this is an asteroid, has nothing to do with biology. This is banded iron, has nothing to do with biology. This is, you should hear it's hysterical, the explanations for stuff like this. They say, oh, this is what they call flat iron. It just happens because of wind erosion. This is a drag in scales. It's absolutely incredible. I show this stuff, it's hard to believe. And this here is just nothing but blood coming out of the rocks. It's hysterical. Now, not only that, there's a lot to understand about fracking and how this is going to affect the water supply. They don't realize it. They're going to break up all the rocks over here. What happens? It gets into the aquifer. It moves down layers of fascia and layers of membranes and tubing, which is the biological tubing of these gigantic creatures. And they don't realize this. Now, I had a friend who was with the Corps of Engineers, Army Corps of Engineers, and he did water remediation analysis of why they were getting contaminations in certain places. You could destroy the earth over here and break it all up and have nasty chemicals over here and think, oh, they're contained because if you were a mile away, you're okay. Well, they found out, no, that wasn't the case. They get down into the layers of the membranes or into the blood vessels, whatever it is. Because the blood vessels are huge, they're gigantic in these creatures, absolutely enormous. Just think of the creatures, the size of them. And they had plumbing in them just like we have. And that plumbing sent the fluids through the body. Primarily the artery was just wide open. Now the arteries have drained out. They just basically drain out, and you get all these caves all over the world. These gigantic caves are primarily arteries. And that's where the water flows through the earth. Leonardo da Vinci drew the same thing. He drew all the pictures of the earth as represented by the body. He was the first one. Leo and I are on the same page on that. So they don't know, and the fracking is a big thing in Pennsylvania, and it's going to ruin their water supplies. Maybe we can get cheap gas, but there's a price to be paid, my friends. And we're expanding our atmosphere so fast that it's nightmarish. And this should be looked at because we might be able to get free energy. We'll be able to walk around with a lunchbox full of free energy. All it is taking light, which is half black and half white, and let's keep the black part here and let the white part come through. Collect the white part, has no weight whatsoever, put it in a battery, go drive around for the rest of your life. You never even have to pull over or fill up. Heat your house, carry this around in the woods, fight fires, because we're going to have a hell of a lot of them. And in my area right now in Connecticut is on fire. And there's no water in sight. It's the worst drought I've ever seen. And there's a lot of people, their wells are going to be run dry very shortly. We just looked out. There's another couple weeks of no rain whatsoever going to happen. This is a really terrible situation. We got fires all over the place. They're going to be burning for, they claim, until we get some major saturation, and they're everywhere in Connecticut. Now I'm in the woods, so I'm a little concerned about it myself. They're right down the street from me. They have a fire. They say they have it contained. Now what does that mean? What happens if we get enormously high winds? Well, I don't know, but I'm as prepared as I can be. So anyway, this is what we're going to do, is just continue on trying to understand our world and the reality of our world, not just what they want to tell you in school. At school right now, they're saying, re-examine the whole thing, go into a trade, go to figure out something, how to fix things. You know, and how to work with your hands, work with your mind. Don't with all this fluff stuff like these science communicators. I want to talk to him. He's talking about string theory and about God and everything else, but they won't talk to me. Nobody will talk. It's a God equation. This is Mikio Kaku. I'm going to be on top of him until he communicates with me. He's a science communicator. We got a failure to communicate. We got us here a failure to communicate. So let's get this done and do some communicating. All right, Miko. Let's do it, my friend. Let's talk. Let's do an interview. Tell me why I'm wrong. Tell me why there is no beef. He says, where's the beef? As far as, where's the particles? Where's the particle? I show the particles. There's no question. The particles exist, and I show them, and we should be able to harvest them. But I need some communication. All right, love you all. Thanks. Bye.